Welcome to AgriBot channel. In today's video, we are looking at how farmers in southwest Punjab tackle salinity, waterlogging, and poor quality irrigation water with a practical wheat-based solution. Let's understand how KRL 210, backed by farmer networks and institutional support, became a strong adaptation strategy in difficult agro-ecosystems. In southwest Punjab, farmers were facing a very tough combination of problems. Soil salinity, rising water tables, poor groundwater quality, and irregular canal water were all affecting crop performance. Traditional high-value systems like mandarin and cotton-based farming started collapsing in many areas. This forced farmers to search for more resilient cropping options that could survive under stress. The study was carried out from 2016 to 2018, with 34 farmers across salt-affected villages in Fazilka and Muktsar Sahib districts. Researchers used field visits, transect walks, focus group discussions, personal interviews, and soil and water sampling. This farmer participatory approach helped capture both scientific measurements and real on-ground experiences. That combination is important when solutions must work in actual village conditions, not just on paper. The soils in these areas were classified as saline sodic, which means both salt buildup and sodium-related soil problems were affecting crop growth. In Fazilka, soil salinity and pH varied across rice wheat, cotton wheat, and quinoa systems, while groundwater salinity and shallow water tables added extra pressure. In Muktsar Sahib, the salinity situation was even more variable and often more severe. When the water table stays close to the surface, salts can move upward and damage the root zone more easily. KRL 210 gained attention because it performed well where many other wheat varieties struggled. Some innovative farmers in the Malout area had already started multiplying and sharing its seed after seeing good results. Later, systematic frontline demonstrations in Abohar gave the variety much stronger visibility and credibility. Once farmers saw stable performance in difficult fields, adoption began to move faster. One of the biggest reasons behind success was not only the seed itself, but the network built around it. ICAR CSSRI, farmers, seed producers, line departments, and KVKs together created a knowledge-cum-seed network. This meant farmers got both seed access and practical know-how on how to use it properly. Such a system is powerful because good varieties spread faster when trust, training, and local seed supply move together. At the field level, KRL 210 gave very encouraging results. In marginally saline fields, yields ranged from 4.4 to 5.6 tons per hectare, with an average around 5.1 tons. In moderately to highly saline waterlogging-prone lands, it still produced around 3.6 to 4.1 tons, which was better than many local wheat varieties, giving only 3.3 to 3.6 tons. In a few lower salinity cases, farmers even recorded exceptional yields of 6.5 to 6.8 tons per hectare. Another important benefit was cost reduction. Farmers adopting KRL 210 were able to reduce wheat cultivation costs by around 15%, which matters a lot in stress-prone areas. The variety also fit well into diversified systems like vegetable pea wheat rotation in Amritsar, where it contributed to both crop diversification and assured straw for dairy animals. So the value was not only in grain yield, but also in making the whole farming system more stable. Over time, KRL 210 spread beyond Fazilka and Muktsar Sahib into districts like Ludhiana, Kapurthala, Barnala, Amritsar, and Patiala. The estimated area under this adaptation reached around 90,000 hectares in Punjab. This expansion shows how planned support from institutions and autonomous farmer-led adoption can complement each other. When both happen together, a local success can turn into a large-scale resilience model. The bigger lesson from this case is that complex farm problems need integrated solutions. Salinity, waterlogging, freshwater scarcity, weak adaptive capacity, and climate impacts cannot be handled in isolation. Policymakers can learn from this farmer participatory model to design better support for degraded lands under similar conditions. It also aligns well with larger goals like land degradation, neutrality, and sustainable development. So the key takeaway is clear. KRL 210 succeeded not just because it is a tolerant wheat variety, but because a strong knowledge and seed network helped farmers use it effectively. If you found this case study useful, like the video, share it with fellow farmers and agriculture students, and subscribe to AgriBot channel for more practical agri-innovations.